Okay, so we've finished the conductivity and bonding lab, so let's talk about what we kind of learned. Because our big question is, why do some things conduct electrical current and other things don't? Salt sometimes conducted it. Sugar never conducted it. So what was going on? Why were these things so different in how they responded to an electrical charge? Well, let's zoom in. Sugar, so if I zoom into that little sugar cube, I get these couple molecules. These are my sugar, my C6H12O6. They're all stuck together and clumped together. And when I put them in the water, they still kind of stayed together. So that molecule stayed together. That formula still looked like the formula underneath that little microscope over there. And water still looked like water. They were just floating around. So let's look at what happened to the salt. Now, when the salt was a solid, there were these little pluses and minuses that were all stuck together. And when I dissolved them, those pluses and minuses spread out. So it no longer looked like this formula. It no longer looked like NaCl. It looked like there's this positive Na floating around, and there's this negative Cl floating around, and water is still water. So as a solid, they were all stuck together, but as a dissolved substance, or a solution, they were all kind of moving around independently. And when we tried it with a conductivity tester, this one was letting my light bulb go off, and this one, nothing happened. Or nothing should have happened, right? So why do some of these things conduct electricity? Well, some of these things conduct electricity because they have ions floating around. So those are the atoms with those positive or negative charges. They're not those neutral ones. So when salt is a solid, those ions can't move. That's why it can't conduct. And when salt has been dissolved, those ions are able to move around and go from one thing to another. They're not stationary anymore. So how can we tell if a substance can conduct? Well, we have to define a couple things first. One is an ionic compound. Now, an ionic compound is something that contains a metal and a nonmetal. So when those solid ions can't move freely, they're non-conductive. But when melted or dissolved, those ions can move around. They can pass a charge from one thing to another. Now, we're not going to talk about it right now, but there are these things called polyatomic ions. That's where we have more than one element stuck together that has a charge. So an example of that is NH4+. Now, a molecule, though, those only contain non-metal items. And it's not one of the polyatomic ions. You're going to get a list of polyatomic ions at some point. And that will be able to determine, am I looking at something that will have a charge or not? And these are the compounds that stay together. They don't fully dissolve, not in the same way that salt does. If we're curious, here's what I want you to have on your periodic table. Now, these orange things over on the side here, these are called noble gases. We're going to actually ignore them for right now. They're not going to be really important to us for a little bit. But the yellow, everything that's yellow here, that is a non-metal. Everything that's green, that's a metalloid. And everything that's white, that is a metal. So when we talk about an ionic compound, if I see one of these white things mixed with one of these yellow things, I have an ionic compound, a metal mixed with a non-metal. Now, if I have a molecule only containing of things over here, I have a molecule, right? A molecular compound. Okay, so these are the things that won't conduct. A mixture of these two things will conduct. So we have to kind of get used to looking at this periodic table and trying to find certain elements. So once again, just to be really clear, an ionic compound has a metal and a nonmetal. The left side mixed with the right side of my periodic table. My molecular compounds, those contain only the right side, only those yellow elements in my periodic table. Now, ionic compounds will conduct when they are dissolved or melted. Those ions need to move. But these molecular compounds do not conduct. Okay. Now let's try identifying a few of these. Can we identify if something is or is not ionic? So have your periodic table and let's go through this. So we have CaCl2. So I'm going to go back here. So I need to find Ca and Cl2. So we have Ca. Ca is a white one. So let's look around. And Cl is over here. So that's a metal mixed with a nonmetal. That is ionic. And then I'm going to put can conduct when dissolved or melted. Next we have SO2. So now I need to find SO2. So can I find the symbol S and can I find O? Well, I know O is over here because that's oxygen, right? And then S. So that's S and that's O. Only made of things that are over here. Only made of those non-metals. So therefore we have a molecular does not conduct. And then, great, so our next one is BaSO4. So let's look at that. So we have BaSO4. There's my S and my O. They haven't changed positions, so that's nonmetals. But where's this Ba? So let's look through. Now I'm just kind of scanning. I'm looking for the big B first, right? There's a BH. There's Ba. So we have a metal mixed with two nonmetals, which that still fits our definition of ionic compound. So we have an ionic compound. And then, again, conducts when melted or dissolved. Okay, we got PbCl2. Let's take a peek at that. So we have Pb. So I want to look through over here for Pb. Let's see. We got over here. We're just doing a quick scan. I'm looking for Pb. There's Pd. There's Pb right there. That's one of my white ones, right? And then what was the other one was our Cl2. We already found Cl2 a second ago, which is right here. So we have a metal mixed with a non-metal, which is ionic. So we can call that an ionic compound. Conducts when melted or dissolved. And then we have CF4. So again, we're going to look over here. We're going to scan, CR, CU, CO. There's a C. I have a C right there. And an F. So I have CF4. So I have one carbon for 4 of these fluorines. It's only made of those non-metals. So this is a molecular compound. Does not conduct. Great. So that's what I want you to be able to do. I want you to be able to look at a formula and tell me, is it ionic or molecular? And then be able to tell me, can it conduct or does it not conduct? And when? Does it conduct as a solid? Does it conduct as a liquid that's been melted or something that's been dissolved? Now, there is one other thing that does conduct too, and that's just if we have a metal. So our Fe, right, our Cu, our gold, right? So all of these things are just metals. So they're metal compounds. They have electrons that are moving between each other. They're being passed around slightly. So just know that they are moving. But if you see one single metal, it conducts as a solid and melted, right? And if it's just one thing, we're not going to worry about dissolving or not dissolving. So it's just a solid, and if it's solid or melted, any one of these things can conduct. So that's my iron, that's my copper, that's my gold, etc. So we can say that those are conductive. All right. So soon we're going to start learning about how to put these things together. How do I make an ionic compound? All right. Talk to you guys soon.